So we're going to go over getting the derivative from the definition of the derivative. And so here's your definition of the derivative. It's the limit as h goes towards 0, and f of x plus h minus f of x all divided by h. Okay? So notice we have divide by h where h is going to 0. Right? So we're not allowed to divide by 0, so something's going to have to work out so that we're not dividing by 0. And here's our function that we're going to do it for. F of x equals x squared. Probably the most classic one to do this, 1, 4. Okay? So we'll actually use that function to see what we get when we use the definition of the derivative. Okay? So what this is telling us to do is take x plus h and sub it in any place that we see x in our function. So we're going to sub in x plus h in place of just x here. Subtract the actual function itself, all divided by h. Okay, so what we're going to get then is the limit as h goes to 0 of, again, subbing in x plus h for the function, get x plus h squared minus the function itself, so minus x squared all divided by h. So then this is, the limit is h goes to 0. X plus h squared is x plus h onto x plus h. Squared means to multiply by itself twice, and then minus my x squared divided by h still. So now you're going to multiply that out. Okay? I'm assuming that everybody at this point can do that type of multiplication, and I end up with the limit as h goes towards 0 of x squared plus 2xh plus h squared minus x squared all divided by h. So now it's all multiplied out. Okay, I'm going to simplify it as much as I can. So in the numerator, there's just a couple of things that I can simplify. I've got a positive x squared here and a negative x squared here that are going to cancel out with one another. Okay, so these are gone. So now I'm left with the limit as h goes to 0 for 2xh plus h squared all divided by h. Now notice everything in the numerator has an h in it and divided by h in the denominator. Okay, so this can be simplified by taking an h out of each one of the two terms in the numerator. And so I end up with the limit as h goes to 0. One of these will cancel and I'll be left with just 2x. Okay. This will cancel with power of 1 here and I'll be left with h. Okay. Now it's easy to see that if h goes to 0, then this becomes 0 and I'm left with just 2x. So there's a very quick, easy demonstration of how to get the most classic one reduced down and get the derivative of x squared from the definition. So I'll show another one on the other board here, a little bit harder, where we're dealing with more than the one term in the original function. Okay? So I'm not going to rewrite the wording on the other board. Okay? I'll just give the function, and then we'll do the derivative from the definition again. So I'll just switch the camera over to the other board. So let's try this function, f of x equals, let's go with x squared minus 2x this time, okay, and see what we come up with. And the definition, again from the other board, okay, has f of x plus h, and so the limit as h goes to 0, okay, subbing in x plus h in my function, any place I see x. So I have an x here, so I sub in x plus h, becomes squared, minus 2 times, I see an x here, so I sub in x plus h. Okay. And then we have to subtract the original function, so subtract f of x. So very crucial here, subtract the whole function. So subtract x squared minus 2x. And I'm subtracting the whole thing. So this has to go in brackets, all divided by h. So again, we have to do some algebra here. Multiply this out, multiply this out. Okay. Well, we know already from the previous example what you get when you multiply x plus h out by itself. Okay. You get an x squared plus 2xh plus h squared. If I multiply this out, I get negative 2 times x gives me negative 2x. Negative 2 times h gives me negative 2h. Subtracting x squared. Subtracting a negative 2x turns it into add a 2x. Okay. All divided by h. Okay. So now we're going to have to do some simplifying in the numerator, once again. So we're going to find anything that I can combine in the numerator. Well, I've got a positive x squared right here, and a subtract x squared right here. So these are going to cancel out to 0. Okay. I've got a negative 2x here and a positive 2x here. So those are going to cancel out to 0. Okay. I look to see if there's anything else that can cancel. There isn't. Okay. So I write down what I have left. So what I have left is a 2xh plus h squared minus 2h, and that's it, all divided by h. So notice once again, every one of my terms in the numerator has an h, okay, but I can cancel the h in the denominator. Okay, so now I can simplify this. Limit as h goes to 0. Okay, canceling h out of both of those, I get 2x plus just an h minus 2. So now it's really quick and easy to see if h goes to 0, and either one of these terms have an h in it, this becomes 0, and I'm left with just 2x minus 2. So usually the hardest part about these is actually getting the multiplication correct at the beginning, and making sure that you subtract what's in the brackets properly. So that I don't, the next step down, the most common error I see is I would see the minus x squared, but I would see people going, keeping this as a negative 2x and not remembering to go subtract negative, so plus a 2x. So keep that in mind when you go to subtract the original function. Okay? And then here is our answer. And you'll see once you learn the rules for derivatives and that you indeed have the correct answer. So at the end of the year, when you know the rules for getting the derivative without going through the definition, and what the correct answer is before you even begin.